In this session, we are going to see the Cartesian System of Coordinates. Chapter 13, Cartesian System of Coordinates for the NIOS Senior Secondary 11th and 12th grades, Mathematics. So let us see what are the topics that are covered, the subtopics that are covered in this session. First of all, the coordinate system and quadrants we will see. It's introduction to coordinate geometry, which you already have learned in secondary grade, 10th standard. Introduction to coordinate geometry. Second thing is about the distance between 2 points. This has already been covered in 10th grade. Section formula, we are going to see the both internal and external division of a line in a ratio, in a given ratio. The coordinates of a point that is being divides a straight line into two sections. That is called section formula. Area of a triangle given its 3 vertices. There's a formula for that, and we will see that. Condition for the collinearity of points. Collinear means 3 points lying in a straight line. If you're given 3 points, you have to check whether the 3 points lie on the same straight line. That is called collinearity of points. The condition for that. There is a condition for that, and we will see that. Slope. Next topic is the slope of a line joining 2 points. There is a formula for that. And then condition for parallelism and perpendicularity of lines. That means what is the condition for 2 lines being parallel and for the 2 lines being perpendicular. Then we have to see the angle between 2 lines. So these are the topics that are going to be covered in this session. Now let us go to the Cartesian system as such. The Cartesian system of coordinates, we will divide this into 4 sections. That is x-axis and y-axis, the 2 axes, the coordinate, they are called coordinate axis. X-axis is the horizontal and the y-axis is the vertical. And we have the intersection, the point of intersection of the 2 coordinate axes is called as the origin. And it has the coordinates 0, 0. With all the points are being referred to with reference to this point, the origin. 0, 0, and other points are being taken from this reference point. We take the points x coordinate, y coordinate. The first, we represent it in the brackets. The first one is called the x coordinate, separated by comma, then we have the y coordinate. Example here, 2, 3 means 2 units along the x-axis and 3 units along the y-axis, the vertical direction. So you have to move in the horizontal direction 2 centimeters, 2 units, and fix the point at that 2, 3. And similarly, the other points. This is the first quadrant. So there is a system of coordinate system. Here there are 4 quadrants. The 2 coordinate axes, namely the x-axis and the y-axis, they intersect at the origin. They divide the graph or the plane into 4 quadrants. You see the 4 quadrants. The first quadrant on the right-hand side, right half. The second quadrant on the left-hand side, top left-hand side. We can remember top right-hand side, top left-hand side. Then that is the second quadrant. Then we move down to the third quadrant, which is the top, which is the left down. So that is to the left and down. And then we have the fourth quadrant, right, and down. These are the 4 quadrants named in this order. First, second, third, and fourth quadrants. Now, in the first quadrant, both x and y axis, both x and y coordinates are positive. The second quadrant, x coordinate is negative and the y coordinate is positive. The third quadrant, both x and y coordinates are negative. And in the fourth quadrant, the x coordinate is positive and the y coordinate is negative. So you should remember this order. Which quadrant, which is positive and which is negative. Which coordinate is positive and which coordinate is negative. We also, the x coordinate is also known as the abscissa. And the y coordinate is also known as the ordinate. So these are some of the basics of coordinate geometry. Now let us move on to the study material of the NIOS. The study material of the NIOS is being shared right now. We see the 13th chapter. Refer to the 13th chapter of the NIOS study material. We find these two figures like 13.3 and 13.4. We have the quadrants. The first thing we are going to see is the distance formula, the distance between 2 points. Directly we go to the formula, that is, if we denote 2 points, P and Q, P is x1, y1. Let us say the coordinates of P is x1, y1. And the coordinates of Q are x2, y2. Then the distance between the 2 points, that is PQ, is merely a distance, and therefore it is written as, it has a formula here, PQ is equal to the square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. This formula holds good for points in all the quadrants, and since this is a distance, there is no positive or negative sign. It's just without sign. It's only a distance, so it doesn't have any sign. So square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. This is called the distance formula. If you take the distance of a point from the origin, then it is square root of x squared plus y squared, where x and y are the coordinates of the point P, any point P. Now let us move on to the next formula called the section formula. This section formula, there are 2 cases. Number 1, the internal division. That means the point lies in between the 2 points. The point of division, or actually, what is this section formula? It denotes the point of division of a line joining 2 points, and in a certain ratio, in a particular ratio, M1 is to M2. Let the ratio be M1 is to M2. And the point of division or the point of section lies in between the 2 points, then it is called internally. So we have to find the point, the coordinates of the point x, y, the point R, which divides the line joining P and Q in the ratio M1 is to M2. Now, the derivation is not required, just directly we go into the formula itself. The formula to find the coordinates of that point of division or point of section. Let x, y be the coordinates of R, the point of division internally, which lies between P and Q, the line joining P and Q. We can say that the point R divides the line PQ internally in the ratio M1 is to M2. We write this way. If you take the coordinates of P and Q, P to be x1, y1, x1, y1, and the coordinates of the point Q as x2, y2, then we can say that x is equal to, the x coordinate of R will be equal to m1 into x2. m1 is multiplied by x2 plus m2 x1 whole divided by m1 plus m2. It's easy to remember this. It's like cross multiplying something like this, m1 with x2 and m2 with x1. And the whole thing is divided by m1 plus m2. And similarly, the y coordinate is equal to, y is equal to m1 y2 plus m2 y1 whole divided by, again, m1 plus m2. So these are the two coordinates, the coordinates of R, the point R, the section, the point of division. If you want to find the midpoint of the point, if R is the midpoint of the line PQ, then the ratio is obviously 1:1. So we get the value m1 and m2 are each equal to 1. So from where we get x, the x coordinate as x1 plus x2 by 2, and the y coordinate as y1 plus y2 by 2. That's quite easy. That's called the midpoint formula. So we have seen the internal point of division or section formula internally, internal division. Now let us come to the case of external division. External division, the same ratio is, the ratio is m1 is to m2. We can assume the same way. But what is meant by external? The external means the point of division, point R, lies outside the line PQ. When the line PQ is produced, you will find that the ratio PR is to QR. R should be the common point. It is not in between, it is outside. See, you can see that. I will just show you this to be clear about this. Here we see this figure. P is this point. Here's the point P, x1, y1, and Q is x2, y2. Whereas the R is outside the line joining the 2 points. It lies outside the line joining P and Q. Let us assume that R has the coordinates x, y. So it is the ratio m1. m1 is PR. This is m1, PR. And m2 is QR. m2 is QR. So PR, PR is to QR is the m1 is to m2. Now let us go into the formula. This formula is similar to the internal division, but there is a minus sign. That's all. m1 x2, x coordinate of R is m1 x2 minus m2 x1 by whole divided by m1 minus m2. Here m1 is greater than m2 because we take the point, m1 will always be greater because the point lies outside, and the point lies outside, as you can see here. P is one end and Q is the other end, and the point lies in the line joining line PQ produced, extended to a point R. That is the point of division. So definitely PR will be greater than QR. Will always be positive here. And similarly, y coordinate is y is equal to m1 y2 minus m2 y1 whole divided by m1 minus m2. This is known as section formula when the point is outside or external. Based on this, you can work out some problems based on this. Examples are given in the book itself. Suppose you want to find out the ratio. A point is given. 2 points are given. The line joining the 2 points. In what ratio does the point 3, this is an example, a typical example where you have to find the ratio given the coordinates of the point of division. 3, minus 2 is the point of division. And the lines or segment joining the 2 points given by 1, 4 and minus 3, 16. Now what we do is we assume that the ratio is k:1. That is the thing we have to assume as k:1. Now, let us take the coordinates of the point P like this. It is the same formula only. We take it as minus. Why the minus? Because x2 is minus m1 x2 plus m2 x1. m1 is k. This case m1 is k into minus 3. So minus 3k plus m2. m2 is 1 here into again 1 because x1 is also 1. Are you able to understand this? So that is the minus 3k plus 1 whole divided by, it's just m1 plus m2, it's just k plus 1. That's all. The formula does not change. Only the ratio has changed. It's not m1 is to m2, but it is k is to 1. Similarly, y coordinate, you can figure it out. 16k plus 4 whole divided by k plus 1. Now the coordinates are given. So you can equate the x coordinate to 3. Isn't it? Say minus 3k and then solve for k. That's all. You can also equate the y coordinate to -2, minus 2, and then get the same value for k. Now, what the value of k is negative in this case, which only says that, what does it signify? If it is positive, it is internal. If the value of k is negative, it's a fraction, of course. 1 is to 3. The numerator is taken as the first coordinate, that is 1 is to 3. Externally, the ratio 1 is to 3. That is the meaning of that. So it is an external point of division. The division is external. Where you can go through the various. This is section formula and the midpoint formula. Given the 3 vertices of a triangle, we have a formula for this. Use the triangle area of a triangle. The 3 vertices are A, B, and C. The triangle ABC, B, the triangle A1. A is vertex A is having coordinates of x1, y1. B has x2, y2, and C x3, y3. Concise formula of 1 by 2 into x1 into y2 minus y3. Within brackets, we have a cyclic order. It's easy to remember this. x1 is there, means it will be y2 minus y3 within brackets. Plus, we have a plus sign in between. If we have x2 here, the next one will always be x2. y2, after y3 comes, see y3, y1. So, y3 minus y1. Then after y1, y2 comes back. It's a cyclic formation. y2, y3, y1, again y2. See, y3, y2, y minus y3. This formula is easy to remember. x1, x2, x3. We add and multiply by half, 1 by 2. This formula is easy to remember, and it can also be remembered in a very concise form as a determinant form. When you come across determinants, we will see this formula, but it's quite easy. Just column wise, you should write x1, x2, x. That's all. And you multiply this determinant by 1 by 2. For evaluation of determinants and other things, we will see it in the 12th standard portion where the matrices and determinants come later on. So we will use this formula itself. This is well and good for finding the area of a triangle given the 3 vertices. Again, area is only a modulus. So modulus means that it doesn't have a sign, so it doesn't have a negative sign. It might have you may get a negative sign in between, but area cannot be negative, so we take only the positive value. We take only the value without sign. So that's how it happens. Here, see, minus 69 by 2 in this example we get. It is nothing but 69 by 2. We take it as the positive value itself. That is and we should write it as square units because the area is in square centimeters, square meters, and so on. So this is about area of a triangle. If a quadrilateral is given, then 4 coordinates will be given. We should divide that quadrilateral into 2 triangles and then add. That is quite simple. This is how you have to do. If area is given and one of the coordinates as a variable there, you can find the value of that variable by using this formula and equating it without those exercises and find out. Next, we would like to see the condition for the collinearity of 3 points. That means check whether the 3 points lie on the same straight line. Collinearity. We can do this in two different ways, but actually this is the easier way. In 10th, you would have, secondary, you would have done a distance formula for this. You would have found out the distances, 3 distances, and then if sum of the 2 distances is equal to the third one, then we say that they are collinear. That is a roundabout method. But directly we can take the 3 points as A, B, and C, and if at all they are collinear, then the area of the triangle ABC is 0. There's no triangle formation at all. So area of the triangle is 0. So we can use the area of the triangle formula and equate it to 0. That's all. So if we equate it to 0, then if we get a 0, if we get 0, the area becomes 0. Then we conclude that the 3 points A, B, and C lie on the same straight line. They are collinear. And it's quite easy. Easy method. So using the area formula itself, we can do this. Next, we pass on to the inclination. Slope is the other definition of slope of the line, the steepness of the line. Inclination is the measure of the angle. Inclination is nothing but the angle, the measure of the angle made by the line joining 2 points with the positive direction of the x-axis, measured in the anti-clockwise direction. It's always the anti-clockwise direction is taken as the positive angle. The clockwise direction is taken as the negative angle. This already we saw in trigonometric functions chapter, previous chapter, in one of the early chapters, the trigonometric functions. Here we see that this angle, this acute angle here, sometimes it becomes an obtuse angle also. In that case, the slope becomes negative because the slope actually is given by tan theta. That is m. It is denoted by small letter m. If theta is the angle made by the line joining 2 points with the positive direction of x-axis, then the slope is given by the small letter m is equal to tan theta. You know that tan theta is positive only for acute angles. If it lies in the third quadrant, it will be greater than 180 and less than 270. So that possibility is also there if it is positive. So there can be 2 values for theta if it is positive. Tan theta is positive. Can either be alpha, it can be alpha. There is one more possibility is that it can be pi plus alpha. So there are 2 possibilities there. Pi plus alpha, that lies in the third quadrant. As you know that tan theta is positive in the third quadrant, first and third quadrants. If at all the line makes an angle of 90 degrees or 270 degrees with the x-axis, or it's a vertical line, the slope of this line cannot be defined or is not defined because tan 90 is not defined, infinite, divide by 0. So it is not defined. So vertical line, slope of a vertical line is not defined. The slope of a horizontal line, on the other hand, is 0. That means it is the angle made by the line joining the 2 points with the positive direction of the x-axis is 0. That's all. For example, angles of and so on. Tan 30 is 1 by root angle also. That's it. So these are the distinct points. Can be, suppose you don't know the angle, you are just given the 2 coordinates. Just 2 points are given and the 2 coordinates are given, x1, y1 and x2, y2. This is an important formula and we are going to see it in the next chapter also, straight lines. The next chapter, next session, we are going to see about straight lines. In that chapter also, we are going to see this formula. So this is a very important formula for finding the slope of a line joining 2 distinct points where we do not know what angle it makes. So the angle is not given. So we just by using the coordinates of the 2 points, we arrive at this formula here. y2 minus y1 by x2 minus x1. That's all. That is a very easy formula. y2 minus y1 by x2 minus x1 may be positive or negative. Depends on the coordinates. And it may be positive or negative. So y2 minus y1 by x2 minus x1. So this formula is used for finding the slope of a given line joining the 2 points given its coordinates. If x1 is equal to x2, that means the lie on the same vertical line. That means the slope is not defined. It's a vertical line. The case of parallel lines, the lines are parallel. Then line parallel to the y-axis or something. They are lines parallel to each other, then it is a 0. Vertical lines are parallel to the y-axis. Horizontal lines are parallel to the x-axis. So this is about the slope of lines. We have some exercises there. Questions are there. We can work out finding the slope using the same formula, y2 minus y1 by x2 minus x1 of the 2 points. Then we can find the slope of the line joining the 2 points, passing through the 2 points. Next, we go to the conditions for parallelism and perpendicularity of lines. That means what condition? Two lines are parallel. The slopes are equal. That's all. Theta 1 is equal to theta 2, the angle made by the two. They are parallel lines actually. The slopes are equal. Even if they are lying on the same line, then their slopes are equal. That's another way of finding collinearity. If the two lines are parallel, L1 and L2, then theta 1 equal to theta 2, and therefore tan theta 1 is equal to tan theta 2, and therefore M1 equal to M2. The slopes are equal. So there are two cases here. One is positive slopes and the other one is negative slope. So there can be also L1 and L2 to be parallel. Tan theta 1 is equal to tan theta 2. So this thing is called the condition for parallelism. Slopes M1 equal to M2. The slopes of perpendicular lines are different. Slopes are different, but they are negative reciprocals of each other, or the product of the slopes is equal to -1, the condition. So what you should do is you take the slope of one line, slope of the other line also, find whether the product is equal to -1. If they are not equal, but they will be negative reciprocal of the other. Or in other words, we say that M2 is equal to -1 by M1. M2 is equal to -1 by M1, or M the other way about. So there is a right angle. The angle between the two lines, two intersecting lines, is 90 degrees or not. So finding the product of the slopes equal to -1, then the lines are perpendicular to each other using the concept of slope of a line. And we have the intercepts made by the line on the axis is given by the x-intercept is given by small a, and the y-intercept is given by small b. These are the intercepts. What is the meaning of intercept? When a line intersects the x-axis at a point, let us say here a, the which is a here, small letter a comma 0 is the coordinate of capital A, the point A here. That's all. And if you take the point of intersection, the intercept, y-intercept, measures small b, the point is capital B here, and the coordinates of B would be what? The coordinates of B would be 0 comma B. The x-coordinate is 0. Any point on the y-axis, remember very easily, any point on the y-axis, the x-coordinate is 0. And any point on the x-axis, the y-coordinate is 0. So the coordinates of A and B, once again, we'll see coordinate of A will be a comma 0, small a comma 0. And the coordinates of capital B, the point B is 0 comma B. That's all. This is how you find out. Intercepts. Vertical line has no intercept, no y-intercept, and a horizontal line has no x-intercept. Finally, we see the angle between two lines. It's a very important trigonometric formula here. We have a trigonometric formula. When there is tan of alpha 1 minus alpha 2. This is actually how we got this alpha 1 minus alpha 2. Let us see. Now, two intersecting lines, we need to find out the angle between the two intersecting lines, that is theta here. we have the angle made by the two individual lines between the positive direction with the positive direction of the x-axis as alpha 1 and alpha 2 respectively. Alpha 1 is the exterior angle of this triangle. You can easily say that alpha 1 is equal to alpha 2 plus theta. Exterior angle of a triangle is equal to the interior sum of the interior opposite angles. So using that theorem, we can write that alpha 1 is equal to alpha 2 plus theta, or alpha theta is equal to alpha 1 minus alpha 2. So that is the angle between the two lines. It's a difference of the two angles, the slopes actually. We can say the angles are here. Let us say it's phi. So we say that tan phi is equal to, we can directly go to the formula m1 minus m2 by 1 plus m1 m2. Actually, it is tan theta, tan alpha 1. That is the idea behind this. This is m1, the slope of the first line. This is the slope of the second line, tan alpha 2, whole divided by 1 plus tan alpha 1. This is an important trigonometric formula identity which we have seen in the third chapter, that is trigonometric functions. One of the identities, tan of a plus b, tan of a minus b in this case. So we have m1 minus m2 by 1 plus m1 m2. You can remember this. This formula gives you the angle between the two lines. If you take the inverse function, inverse tan inverse, you will get this, that the angle. That's it. Inverse we will see later. And these are the example problems. Using some standard values. If 45 degrees means it is, if the value you get is 1, then it is definitely 45 degrees. We can say that it's 45 degrees. But tan theta is, tan of this, tan theta is 1. And other than that, we can say the slope of the line can be found out. If the angle between the two lines is given and one slope is given, then we can find the slope of the other line using the same formula. m1 minus m2 by 1 plus m1 m2. Shifting of the origin is shifted, then we can say that there is a translation of axis. O is shifted to O dash. You will have the reference points changed. With respect to this, the coordinates also will change. H. So rather x plus h and y plus k. That is now the new origin. That's called. It's called translation. You'll see the circles chapter, where the center is being shifted to other than origin, center of the circle. So let us see that. Let us sum up this chapter. In conclusion, we see that we have seen the following topics: distance formula, distance between the 2 points. Then section formula, is internal is this formula m1x2 plus m2x1 by m1 plus m2, comma m1y2 plus m2y1 by m1 plus m2. The coordinates of the point of division of the line segment joining the 2 points x1, y1 and x2, y2 externally are given by a ratio where there's a minus sign in between them. So that is the difference between these two. The same formula, but the only thing, the negative sign in between the two, m1 minus m2 here. And the midpoint formula, where the midpoint, the line segment joining the points x1, comma y1 and x2, comma y2, the midpoint is given by x1 plus x2 by 2, comma y1 plus y2, whole divided by 2. Triangle formula, we can also write this in this form or in this form of x1 into x1, we have it to x1, and also y2 minus y, x1 into, and we group it actually. This is a grouping term, but when we write it in that, this is an expanded form. It's after grouping it in like this, or the determinant form. Then the slope of the line is given by, if you want to calculate, tan theta is the slope actually, the angle, tan of the angle made by the line joining 2 points with the positive direction of the x-axis, tan of that angle. Slope of the line m is given by, the 2 points are given, then we can also write it, we can find out the y2 minus y1 by x2 minus x1. Then we saw the slopes of parallel lines, they are equal. Perpendicular lines, the product of the two slopes, the slopes of the two lines will equal to minus 1. And we finally have the angle between two intersecting lines with slopes m1 and m2 given by tan theta is equal to m1 minus m2 by 1 plus m1 m2, where 1 plus m1 m2 is not equal to 0. That's the condition. And then we saw the shifting of the origin h comma k. So this is a session now on coordinate Cartesian system of coordinates. That's it.